Welcome to Tech Kevin. Today we are demystifying network hardware. Seriously, we're going to build a complete mental map of your home or office network architecture. We're mapping out exactly how your data travels, all the way from your internet provider's infrastructure out there in the street, right down to the specific piece of hardware you're holding in the palm of your hand right now. Okay, let's dive into this step-by-step journey. We'll kick things off with modems as your gateway, move on to routers acting as the traffic cop, look at how to expand things using switches and APs, check out firewalls as your network bouncer, and then finally wrap it all up with NICs, the unique fingerprint of your device. So, part one, modems, the ultimate internet gateway. Now, modem actually stands for modulator demodulator, which, perfectly describes exactly what this thing does. See, your internet service provider sends data through the cables in your wall using analog signals. But your computer, well, it only speaks in digital ones and zeros. So the modem is this absolutely crucial translator. When data comes into your house, it demodulates those analog signals into digital data that your electronics can actually understand. And when you send data out, like uploading a photo, it modulates your digital data right back into analog signals so they can travel across the provider's network. Depending on your specific setup, your modem might look a little different. It could be a cable modem, using the exact same coaxial lines as your TV. It could be DSL, using old school phone lines, or fiber for those blazing fast fiber optic connections we all want. You might even have a satellite or wireless cellular modem. But hey, no matter what the physical medium is, its job remains exactly the same, pulling that internet connection directly into your building. And honestly, the golden rule here is pretty simple. No modem, no internet. It is literally your ultimate gateway to the outside world. I mean, every single device downstream completely relies on this one little box, successfully translating those signals just to get online. Moving right along to part two, routers, your network's traffic cop. Now, people constantly confuse the modem and the router, but they do entirely different jobs. Think of it like this. If the modem gets the internet connection, the router shares it. Your laptop, your smart TV, your phone, your gaming console, they all want a piece of that internet at the exact same time, right? Well, the router is the device that steps in and makes that shared chaos possible without the whole system just crashing. It pulls this off by creating what we call a LAN, or a local area network. The router basically assigns a private local IP address to every single device so it can keep track of who is who. Using something called network address translation, or NAT for short, it cleverly allows dozens of your local devices to securely share that one single public IP address that your modem provided. So picture this. Your laptop requests a YouTube video, and at the exact same time, the TV is streaming Netflix. The router uses its internal routing tables to figure out the absolute fastest path for that data. It directs the right packet to the right device instantly, acting literally just like a master traffic cop managing a wildly busy intersection. All right, on to part three, expanding your network with switches and APs. Now, what's really interesting about this slide is the evolution of how we actually connect multiple wired devices. Today, we use a switch. Decades ago, we used things called hubs, but hubs were, they were dumb. They would just blindly blast incoming data to every single port, which clogged up the network and caused all sorts of data collisions. Switches completely killed off hubs because switches are smart. They maintain a MAC address table, meaning they know exactly which device is plugged into which specific port, giving every single device its own dedicated bandwidth. So, let's say your standard router only has 4 ports on the back, but you've got a killer gaming room with multiple consoles, a PC, and maybe a network-attached storage drive. You just plug a switch into your router and boom, instant wired expansion. You can pick up switches with 5, 24, or even 48 plus ports. They handle all that heavy local traffic effortlessly, and they do it without needing to assign any new IP addresses. But what about Wi-Fi? For expanding your wireless coverage, you don't use a switch, you use a wireless access point, or WAP. You just connect the access point to your router or switch using a physical Ethernet cable, and it essentially acts as a bridge. It broadcasts a massive, fresh Wi-Fi signal specifically for your phones, laptops, and smart home gadgets. Now, keep in mind, access points don't actually route traffic. Your router is still doing all the heavy lifting behind the scenes there. They just add huge Wi-Fi coverage zones. They support modern standards, like Wi-Fi 5, 6, or even 7. They can handle hundreds of simultaneous connections, and they typically give you an indoor range of about 100 to 300 feet. This is exactly what hotels and big businesses use for that seamless Wi-Fi coverage, and let me tell you, they are vastly superior to those cheap wireless range extenders if you're trying to fix home network dead zones. Let's move to part 4, firewalls, the bouncer for your network city. Your firewall is fiercely protective. You see, every piece of data coming from the internet travels in little envelopes called packets. When a packet arrives at your network, the firewall steps in and rigorously inspects it. It wants to know, where is it coming from, where is it going, what port is it trying to use, what's the protocol. It takes all this information and compares it against strict security rules. If the packet is safe, it passes. But if it's an unauthorized access attempt or from a known malicious IP, the firewall blocks it dead in its tracks. No entry. Now, your standard home router actually has a basic hardware firewall built right in to protect your whole network all at once. Pretty handy, right? Sirius business setups, on the other hand, will use dedicated standalone hardware firewalls for even more granular control. And on top of all that, your individual laptop or PC will run a software firewall, think Windows Defender or the Mac firewall, acting as a secondary backup layer just to control what specific apps can and cannot do. And finally, part 5, NICs, the hardware fingerprint. So the crucial point is that every single connected device, whether we're talking about a giant desktop PC or that tiny smartphone in your pocket, absolutely must have a network interface card, or a NIC. This piece of hardware sits right between your device's motherboard and the network itself. It is the final translator on our journey, converting your computer's digital ones and zeros into electrical pulses for an Ethernet cable or into radio waves for your Wi-Fi. And here is the real magic of the NIC. Every single one has a MAC address permanently burned into it at the factory. This is a totally unique hardware fingerprint. Literally, no two NICs in the entire world have the same MAC address. This unchangeable ID is exactly how your router and your switch know they're sending that incoming Netflix data specifically to your living room TV and not accidentally blasting it over to your neighbor's house. NICs generally come in 2 main flavors. You've got wired NICs, which give you that physical, rectangular Ethernet port handling speeds anywhere from 100 megabits all the way up to lightning-fast 10 gigabits and beyond. And then you have wireless NICs, which handle your Wi-Fi antennas. Those are usually hidden right inside the motherboard of your phone or laptop, or sometimes they plug in via a simple USB adapter. And just like that, our data journey is complete. By understanding that a modem translates, a router directs, a switch expands, a firewall protects, and a NIC connects, well, you can now see this as a complete, logical, interconnected system. You are now fully empowered to actively troubleshoot your own network problems, make smart upgrades, and really optimize your setup. So, I'll leave you with this provocative thought. The next time your connection lags or your video starts buffering, will you just blindly blame your internet provider's speed? Or will you look at the blinking black boxes in your home and realize it might just be time to upgrade that ancient router? Thanks for joining me on this explainer, and don't forget to like, subscribe, and share for more tech tips.